If we think about it, we'll find that the change in kinetic energy for the red object will be very, very small simply because its mass is so large. Now, why is that? Well, these two forces, Fry and Fyr, must be equal in magnitude but opposite in direction. So these are actually Newton's third law applies to these, and these are third law pairs. This is a third law pair. So if we think about that, the force acting on the very large object has a lot more mass to accelerate. Therefore, the speed that it attains due to the force of the yellow one acting on it is going to be much less. Therefore, we can say that the change in kinetic energy of the red object is very, very small. And also, let's take a look at this integral right here. So this is the first integral we had up previously. This was pertaining to the red object. And let's think about what the line integral really represents. The line integral takes into account this force, Fyr, but also it requires a displacement vector or differential vector, and then a displacement over some path. And of course, if we think about it a little bit further, we'll realize that because this is so massive, the red one, then the path change will be very, very small. So although Fyr could be very, very large, the total path difference between Si and SF is going to be very, very small. Now let's look at another example. So if both objects start at rest and have equal mass, do the two integrals cancel for the combined isolated system? So now we're thinking about the two objects together as the system, as before. And we come back to the result associated with that perspective. So change in translational kinetic energy for the red object, change in kinetic energy for the yellow object, and then those individual integrals that we had seen before that we immediately identified as changes in potential energy of the individual objects. So let's think about this. These two objects, in terms of their mathematical form, seem like they may cancel because if we think about it, Fyr, as we just mentioned, has to be equal to Fry, but offset by a minus sign. So the same magnitude, but opposite directions. So if that's the case, then it appears that by switching the sign on one of these integrals and equating the magnitudes of these two forces, then we should get a cancellation in terms of these two integrals. Now, the answer is no, and we have to think about a little bit further why that would be. So it's indeed the case that each of these forces correspond to, together, form a third law pair. That's true. But indeed, the fact that the displacement of each one of these objects points in opposite directions is also crucial to take into account. So as the red object is drawn towards the right, the yellow object is drawn towards the left. And that switching of direction is encoded inside the dot product here. So the sign change will then recorrect the minus that we would acquire by our first assumption and cause both of these then not to cancel each other out. Okay, so that concludes the third topic in Block 5, and we'll move on to 5.4 next time.